Welcome to the two-part session, The Future of HVAC is Healthy Homes. I am Larry Zarker with the Building Performance Institute.
I'm Kevin Kennedy with Children's Mercy Hospital in Kansas City. Welcome. Glad to have you here.
Hi, I'm Joe Medosh. I'm a healthy building scientist with Hayward Score.
So today's session is entitled Learn How to Make Your Students Leaders in the Industry, and we will cover 4 of the 8 Keep It principles. In part 2 tomorrow, we will discuss why healthy homes matter and the 4 Keep It principles we don't discuss today. In today's session, we will provide an overview of the concept of healthy homes and focus on keep it clean, dry, pest-free, and ventilated.
So let's start with an example of how this is all going to come together over the next 2 days. So here's a holistic approach as to when one thing can actually impact multiple conditions in a home. So many of you may have experienced this personally, is that you actually have some type of moisture or water intrusion. This doesn't have to be a flood. This is just a constant water condition that's around the perimeter of the house or somewhere we're actually getting moisture that's coming in and impacting the house. It can actually cause visible conditions that we refer to as mold or fungal growth or whatever you want to call it, that clearly now has other issues that now impact the occupants and the durability of the home. And this shows up as an increased asthma and allergy symptoms. So we go back to our moisture and talk about structural damage. Structural damage is also causing issues with paint that could be deteriorating. Now we are actually having more pests because pests like the moisture, and now there's actually more openings for them to get in, as well as fire risk from gas lines shifting and other stuff, as well as a number of injuries that are happening from all of the concerns that are happening around the structural damage of the house. So let's just use one example of those. So we have pests that are now getting into the house and using the house as a moisture source and a place to hide. And so the occupants are now using pesticides to try and eliminate these conditions. Those pesticides and the pests themselves can actually now go back to increasing asthma and allergy symptoms. You can see there's a circle that's happening here. So the pesticides also can impact food that people may have in their house or their children, and other conditions that show up in the house. So you can see that one moisture issue can cause multiple conditions from deterioration, causing concerns with asthma and other allergies, and other poisons that can be in the house. So when one thing impacts the other, you realize that I now need to be a holistic approach with the house and the occupants themselves.
So what Joe has shown you is the comprehensive connections between one issue in a home and how it can lead to other issues and hazards in the home. But when you're thinking about homes, there is another important component, and that's to think about the people who live in the home. And one of the important things for your students to understand is part of their effort might be focused on the home, but part of it for the future really has to be focused on the people who occupy the home. What are their concerns? What are they worried about related to their home and related to the heating, cooling, and other systems that are used to maintain the home? Are there hazards in the home that you might observe as you walk through a home that you might want to inform them about that maybe they don't know much about? And part of this kind of training that this presentation is about understanding and being able to communicate with people about these issues in their homes. So when we think about homes, we have to understand that many kinds of shelters people define as home. They all have the common idea that within that space, we're trying to maintain the same level of comfort, the same level of humidity. So regardless of whether a home is in Alaska or in Florida, Maine or Colorado, all homes, all spaces, we're trying to maintain the same indoor conditions. So within the concept of healthy homes and in the concept of building science, we think about the home as a system. And the systems of the home are directly impacted by these four classic elements that we like to think of: fire or heat in the home and how it's transferred, air and how it moves through the system. Most of the people who occupy homes think of it as a compartmentalized structure when all of the air within that space is shared from the crawl space up to the bedrooms, from the basement up to the upper floors. How the water moves through the system and is transferred, and how earth or particulates or dust might come in from the outside or move around on the inside. So we think of homes as systems, and they're a complicated system, as you all well know. But also, when you think about people, they are also a complicated system. As you can see here, a very complicated system. But there's a lot of similarities between the two in that there are lungs in the person, just like there's an air handler in the house. There are systems to manage water movement through the house. There are systems that manage blood flow and circulation through a body. So there are lots of pieces of a human body that create the one system, and there are lots of components of a home that create a system. And all of that system has to work in a comprehensive, holistic fashion.
I'm going to draw from my own personal experience to describe two home health issues that HVAC technicians could easily identify. The first is a chronic wet basement, as seen here. That growth on the walls is just 15 feet from the furnace's air handling unit. The air circulates throughout the house for people to breathe and finally meets the filter at the end of the return. Yes, I was the cobbler whose kids had no shoes. Yes, what could possibly go wrong? Here's another example. I had this heat pump unit serviced several times by technicians, and the technician never pointed out that there was a slope toward the corner where rainwater could collect. Let's go down to that basement. This bookcase is up against the CMU wall. We started noticing a mildew smell and removed the books to discover rotting wood. So we removed the books, removed the trim, pulled the bookcases out to expose the drywall. This is what we found. The drywall was not dry, it was wet and covered with microbial growth. So we pulled the drywall to expose the fiberglass bats and then the framing, which was rotted. The source of the water is a slope toward the wall and behind the heat pump unit. Not much water gets in, but it can't get out. A little bit of water can cause a lot of damage. HVAC technicians can be the customer's hero by pointing it out before the problem gets bad.
So we want to take a short break at this time to let you know about a new training reference guide and certificate available from BPI. It's called the Healthy Housing Principles Reference Guide. This is a new guide that we're going to be talking about today that's available, and you'll hear more information about that. There's also a certificate of knowledge that someone can obtain by taking an exam that's related to the reference guide. The guide covers the 8 healthy home principles that we will discuss today, and there's special pricing for any of you HVAC professionals and instructors who would like to adopt these principles and the training information for your classes and students.
The healthy housing principle is a complement to the existing building science principles that BPI has had out for about 8 years. This may be something you're already using in your classroom, and if not, you want to maybe use this in combination with the healthy housing principles. This one is really based upon some of the building science fundamentals like transfer of heat, air, and moisture, and the 4 Ps: pressure, pathway, pollutant, and people. It does an awesome job of actually including and explaining some of the diagnostics that go along with weatherization and other conditions you may want to do in the house. So fantastic book. Also, of course, there are some discounts for you who are the viewer. So you want to reach out to us at the end. We've got links to how to do this.
And for nearly 3 decades, BPI has provided professional certifications to technicians who upgrade the performance of homes. As you can see, the heating and AC heat pump professional certifications directly relate to HVAC technicians. In 2012, we added 4 certifications with support from DOE and NREL for the Low Income Weatherization Assistance Program.
Welcome back. An important thing has happened in the last year. With the COVID pandemic, the world has changed. Here's an electron micrograph of the SARS-CoV-2 virus. That virus has led to a complete change in our society and those in other parts of the world. It's led to a complete pulling back from going to work, from people having to stay home, or maybe even working from home, working remotely. So that means before, people were spending something like 70 to 90% of their time in an indoor environment. Now, because of COVID and its impact on our society, people are having to work from home as well as balance that with their normal activities with their family. Kids are having to do all of their classroom work from home remotely. A tremendous challenge for the whole family, but it's all occurring in the same indoor environment. So people are now spending 90, 95, 100% of their time in that indoor environment. So the air from that system is what they're directly dependent on. If you can think of it about their normal breathing, if 90% of their time is spent indoors, that means 9 out of every 10 breaths are coming from the indoor environment. So people are really focused on and wanting to invest in the best indoor air quality they can get in their home because they're spending so much time there. So they're consciously thinking about the performance of their heating and cooling system, thinking about making their home quieter, more soundproof, and looking for ways to improve the comfort in their home because that's where they're spending most of their time. And for the foreseeable future, that's a place where they'll spend that time.
So you've seen lots of information so far, and all of this has been brought into the Healthy Housing Principles Reference Guide. And I want to reiterate the term reference guide because this is a phenomenal resource. So it isn't something that you're going to read about in terms of like, oh, what could be an issue. This is a resource that not just tells you about what you need to know, but tells you where it came from and what are some of the great places where you can learn more about these fundamental principles of clean, dry, pest-free, contaminant-free, safe, ventilated, comfortable, and maintained. All of these go into in-depth in terms of the resources that are there and the things you can look up at any time and come back to and learn more about how you can apply them, not just for your own home, but working with clients is a great way to use this as a reference guide. So today we're going to focus on 4 of the principles. Keep it clean, keep it dry, keep it pest-free, and ventilated in terms of how that applies to this session. And our next session tomorrow, or part 2, will be keep it safe, keep it comfortable, keep it maintained, and contaminant-free. So between the 2 sessions, we'll actually cover in depth all of the 8 principles.
So the reference guide is filled with images, graphs, and tables that support the narrative. Each chapter provides a list of terms and a set of concepts that students need to know. For example, one of the concepts they need to know is what are the potential health issues relating to an unclean home. Cleanliness is a basic building block of healthy housing, especially during this pandemic.
Well, one of the things you hear a lot about is PM 2.5 or particulate matter or size. You may hear PM 10, sometimes PM 1. All these are describing the particulates that are around us and what we're breathing constantly. So this is a great illustration from the EPA that shows compared to a human hair or fine sand that we see on the beach, this is the size of the particles that are getting into your lungs. In the upper left-hand corner, you can see how far they get into your lungs. So some things are actually grabbed by your nasal cavity and your throat, your esophagus, but some things get into your lungs. Some things get so deep into your lung that they actually enter your bloodstream. So this is a good example to show that. And since SARS-CoV-2 or the COVID-19 virus has showed up, we added that in terms of the scale of a blood cell. So you can see how small these things are and why they've caused so much havoc in the lives of people throughout the entire world. It's so easy for these to become ingested, and why masks are the simple source to preventing these things entering your body. Here's an example of how much air you are breathing in a day. So 3,000 gallons, represented here as a pool in terms of water compared to air. So if you are imagining, the 3,000 gallons, that's the air you're breathing in, and going back to the particles that we now know have an exposure element. So these are serious conditions, and why we want to make sure we are controlling those in the environment and in our heating and cooling system. You are one of the primary groups to control the lung capacity, and think of the lungs as the HVAC system, as Kevin mentioned earlier.
So when your students think about the healthy home principles that we are advocating that you teach them, really keep it clean has changed. Everybody has always thought of cleaning as a way to keep our homes looking nice and organized. But the truth is, with healthy homes, cleaning is really about reducing exposure. All of the cleaning activities you might be doing in a home are to remove settled dust, particles, residues, slimes, whatever on surfaces, and ultimately that eliminates how much of it is in the air or how much gets distributed. So we're trying to reduce the exposure to the chemicals, to the allergens, droppings, and dust, things that people might have an allergy to, or that might lead to asthma symptoms. So our goal with clean is to reduce the exposure to contaminants. So when we think about dust in homes or particles, we're thinking about the where do those particles come from? What is the source? And common sense, there are two common sources. Some of it infiltrates in from the outside, a little over half, and that's made up of outdoor particles, being dirt, pollutants, tire particles, pollens, miscellaneous things from the outside. And indoor dust comes from sources indoors. So that would be the household chemicals used, the pesticides, potential allergens, any kind of smoke or incense that might be burned inside, cooking activities, pets if you have them, the dander from the pets, the fur, all of that can build up on the inside of a home. And it's important for your students to understand where these contaminants come from.
So throughout these sessions, you're going to see that we talk about things in the home that we want to have you explain to your students and enlighten them as to their vision should be more than just looking at the box that they're there to service, that they're understanding more about the capacity. And we also want to give some examples that go specifically along with what they're actually being trained to do. And here's an example of an upgraded furnace where they're actually changing the standard filter location and type and size to actually create a better system. And we actually have data that shows why something like this is so effective. So on the left, this is actually a MERV 12, which is a high MERV rating. MERV stands for the amount of particulates that it's capturing. But you can see by how it actually enters the unit that it's a struggle to actually capture those units, as well as the amount of pressure that moves through the system is high. The higher the pressure, the more it is a strain on the system. So then they had a contractor come out and relocate this system, making the filter much larger and making it so that all the air is being caught by the filter. And I have some data on the next slide to show that. We want to give a special shout out and thanks to Linda Wigington at Raucus. They're out of Pittsburgh, and they have great data. You can find them online if you want to learn more about this and what they do. So here's an example of they have a air handler with a high MERV filter. And they show right now what they had prior on the older system, which was on the left, and then what happens when they moved it to the new one. So red is kind of bad, orange is bad, green is good, and they actually had them on their the outdoor example to show what was being infiltrated. They have an indoor, and the roamer was in the bedroom. And you can see by just redoing the filter on one of their main air handlers, the amount of particulates that were removed. And this is actually using a very high accurate particulate counter to determine that this was actually doing well throughout the house. So something as simple as actually doing a great job of locating and making low pressure filter systems has a great impact on the occupants.
You saw the example earlier of water seeping into a basement on a sloping grade next to a heat pump unit. HVAC technicians could be on the front line of Identifying such concepts as how moisture can enter the home and simple steps for controlling moisture. Here are a few terms and concepts that they will learn.
It's important for your students to understand that the research evidence shows there are a host of health effects that are associated with living in a home with chronic dampness. That chronic dampness is known to be associated with the proliferation of microbial agents, whether it's molds or bacterias. But we know from the research evidence that the chronic dampness changes the indoor environment in the house for the worse and ultimately leads to a wide array of potential health effects, not just for the people like these children with chronic health problems, but really for all the people that might occupy that damp environment. And it's also important for your students to understand what all the sources of moisture are. It isn't just the bulk water, rain that might come in from the outside, and how does that infiltrate from the outside. It's also all the plumbing sources, the human activity sources, whether it's from showering or cooking. It might be from the animals or pets that are in the home. It might be from too many plants in a home. There is a host of moisture sources, and you have to factor those in when you're thinking about moisture management as part of the total management of the indoor air and indoor environment, if you will, of a home.
So dry has multiple different applications, as you could see here, that we try to apply back. So kitchen ventilation is one that we don't think of it immediately as an HVAC contractor, but that is one of their roles to install the fans in the bathroom and set up the fans that are working in the bathroom and the kitchen. So these are the places where we have high moisture content, and now they're helping to control that and eliminate that. It has a huge impact on the entire house, even though these are localized areas. And you can see here that even the units themselves, especially when they have a air conditioning coil set with them, that there's a lot of moisture options that actually can cause damage to the units themselves. So dry and actually keeping it the moisture under control and relative humidity, vapor, and solid water is a huge component to making sure the system works well. It also has an impact on creating, potential mold growth. We've talked about that. Or when it gets too high, now you actually have dust mites that can appear throughout the house, and it is a huge comfort factor. One of the things that people forget about is humidity makes people uncomfortable. That's why they're on the phone calling your technicians to come out and figure out what's going on. If you can't control or remove the humidity, especially in a cooling capacity, you're realizing that your system is not working well. The book, all the reference guide also goes through the understanding relative humidity and how to understand between low and high and what happens when you're over 60 or you're below 40 or into that 30 range. All those kind of things really are things your students need to understand.
So it's important for the students to understand this relationship between chronic dampness or how moisture is managed, and when it isn't managed well, when there is chronic dampness, how that leads to microbial growth. And that microbial growth most often is found on surfaces. Microbial things, mold, grows on surfaces. So it grows on those surfaces because of the available moisture that's at the surface. It's not just about the moisture that is in the air and circulating through the house. It's how that moisture moves through the home as a system. So your students will learn what that relationship is between the dampness and moisture balance in the home and the potential risk for any kind of microbial growth or activity. We also want to point out that it's important to understand that the Keep It principles themselves are closely related to how we manage our homes in response to COVID-19 and trying to reduce the potential risk for exposure and for infection in an indoor environment. So moisture is one of those things that we're thinking about, and it turns out higher humidity in a home actually can help reduce the spread of viral particles. So it's important for students to understand, especially now, more and more students and more professionals are being asked for advice and strategies for reducing the potential risk for some kind of infection in a home environment or other kinds of buildings. So what are some of the effective strategies? And moisture is one of those important strategies for controlling the potential dispersal of COVID-19.
COVID-19 enlightened us on a lot of conditions like the impact of humidity and particulates, as well as particulates themselves and filtration. So we have come a long way in this year of catastrophic conditions to learn more about controlling our environment. I want to give you guys an example of what the moisture can do in a house and how people forget about what's outside and how it actually is becoming inside your house. So most people think about bulk water, as Kevin mentioned, the rain, the water that's outside. Clearly, our roof and our entire exterior are trying to keep that water from coming inside. But if you don't have good drainage, as we started on the very beginning with the holistic approach, that actually will impact not just with having direct water in. Think about this as water and now vapor condition. So now we actually have vapor that wants to move from the wet condition to the dry condition. That's its natural state. That's the building science component, is that wherever it is dry, the moisture will want to move into that. So now that we've actually understand that things want to move from wet to dry, now we have to understand that we also have air leakage. I represented air leakage as this green gooky stuff between the air leakage and the moisture conditions. The two of them are trying to find a way into your house. They want to move from the higher to lower pressures. Okay, so now we have it in, and now what's happening is that the moisture is moving throughout the structure itself. So when I have water or conditions in my basement, even below the slab or in the crawl space, those things are moving, that moisture is moving through those materials, through the house. So you wonder why you're uncomfortable on the third floor. It could be what's happening in your crawl space. All that stuff moves all the way through and finds its way to stop in your attic. And so depending on what kind of system you have for ventilation, or what type of plywood or what kind of conditions are in there, you may find that your attic is well vented, or it is actually capturing and stopping the moisture. And depending on what type of insulation system you have at the roof line, could be something that is a catastrophic event that's a long-term way of moisture finding its way through that system. So again, you want to make sure you have a holistic understanding of the house and how it's built to understand the moisture that moves through that structure.
Now for another promotional message. We encourage you to fold the Healthy Housing Principles Reference Guide and Certificate of Knowledge exam into your HVAC curriculum. In order to do this, there is a special offer today.
So we're offering for you today, for HVAC's excellent participants and particular instructors, a special Healthy Housing Principles Train the Trainer session. We will cover these important topics through using a Zoom platform. We'll go over the Healthy Housing Reference Guide. You'll get a code for the exam book. You'll get access to a folder full of images and PowerPoint slides and other things that you can use for teaching the class. There's a model curriculum available for your use, and the development of a live learning network where you'll get access to technical questions and the ability to ask technical questions for the next year as part of the program.
Kevin and I have been doing Train the Trainers for probably 5-6 years now on these and similar topics. And you can see that we've been doing this across the country. And we used to be able to do them in person, and we hope to someday be able to bring that back. Currently, it'll be a Zoom Train the Trainer, and I'm sure you're used to working in that kind of network as you watch a video right now. So here's the special offer to make sure you understand some of the details. So there is a free reference guide that's included in the price. You get a free exam. You get the Learning Network annual fee, which means we all get together once a month to talk about what you or some of your students are asking about, and the actual training itself is a $500 value. All that's $800 for the amazing offer of just $300. So $300 gets you this training and gets you all of these resources, including some of the other ones which were online access to all the images and some of the content. This is a turnkey offer. When you are finished with this, you'll be able to integrate this into your existing curriculum however you see fit, and you'll understand how to present the material. We think it's an exciting offer. To learn more about it, give us an email. Send an email to hhlearningnetwork@gmail.com. Again, hhlearningnetwork@gmail.com. All of these resources will be repeated at the end, so you have access at the end of the video. Thanks again.
Welcome back. Why do HVAC technicians need to know about pests? First of all, they should be able to identify signs of the presence of pests. and know what impact it can have on occupant health. Also, as you will hear in a minute, air infiltration pathways into a home not only increase energy load, but also are considered contaminant and pest pathways.
But first, we have to start with the basics. So when it comes to pests, everything you learned about how to manage pests, you all learned probably in about second or third grade biology class. And that is that all living things need food, water, and a place to live. And that's true with pests. And it turns out the most effective way to manage pests is to control their access to food and water and isolate their ability to establish a nest or a habitat within a home environment. The other important goal of Keep It Pest Free as a healthy home principle is to reduce the amount of pesticides that are used in homes. The vast majority of the population shows evidence of pesticide exposure, and it comes from the routine use of these chemicals in our homes. So our goal is to reduce the need for chemicals and pesticides. People tend to use much more than they really need for the situation, and they often use the wrong kind, and people have a tendency to not read labels. So within the healthy home training and within the reference guide, we emphasize the importance of reading the labels, but also being smart about when to use pesticides and really try to apply alternate strategies that are ultimately more effective. And the one most important strategy for pests that we emphasize is called integrated pest management, or IPM. This has been around actually for decades and has been used by most federal agencies and many state agencies and lots of community programs. Very well established practices. It's not a special type of practice, been around for a long time. And this pyramid on the right here shows the basic strategies. Make changes to the design of the home, eliminate access to food and water, and then you might need additional controls and possibly need pesticides. But the goal is to use them as a last case need instead of a first case. We're not saying you might not need pesticides. We're just trying to minimize the time and amount that might be needed or used. So there are very simple steps to the integrated pest management process. And as Larry alluded to, you can see on the outside of this building here, the pipe access, that's a common pest access, but it's also a point of air infiltration and a point of moisture infiltration. And it's a common point where an energy efficiency person might come in and seal those to eliminate the air leakage or eliminate the water leakage. But that's also an opportunity if it's properly patched by putting a pest-proof material in there before it's sealed, you can make it a pest-proof point. So the goal is to systematically go through the home, do an inspection, do this physical exclusion, isolating the ability to get in the home, education to the occupants of the home, improving general cleanliness and sanitation, keep it clean, and then physical control and monitoring of the environment for any future pests.
One of the things that you are the keepers of is the system as well as the ducts that are part of the system. Most of the units you probably are teaching have a duct component, understanding that some may not, but in general, making sure that your ducts are airtight also helps them be moisture resistant, as well as keeping out pests. Pests want to find moisture. They want to find a food source. So the best you can do is eliminate those conditions. So we promote duct testing, duct sealing, using duct mastic. A variety of those components will help make sure that the air that you want to go into the house itself is designed and actually goes there. But you're going to find out that are a variety of components that have been compromised, or things got into the attic and got into your equipment. And so the understanding about not just spraying it out with air, but understanding that why did it get there, how did it get there, and how to prevent them from returning is one of the things you're trying to make sure your students understand, not just from the units inside the house, but also the things on the outside of the house. Many of the conditions you may find as a service condition were actually caused from either poor maintenance or other challenges that allowed rodents or something else to get into the system.
V may be the most important letter in the HVAC acronym. It is important that your students not only know about ventilation, but also can take simple steps to improve ventilation and air quality. These terms should become commonplace as they move into a career in HVAC.
So it's important that your students understand that uh, ventilation is fundamental to good indoor environmental quality, and we know that poor ventilation is strongly associated with a host of health effects. Some of those health impacts are listed here, and some that your students and maybe you, if you've worked in the field, have heard these reported from the residents or occupants of homes. It's not uncommon to have respiratory irritation, especially in upper airways. Common colds and flus are strongly associated with poor ventilation, as well as pneumonia and bronchitis. Bronchitis being just congestion and infections of the upper airways, and that's because of the contaminants and particulates and things that are not being adequately removed from the air, either by good exhaust ventilation to remove things or by the circulation and proper filtration within the system. Again, thinking about the home as a system. So here's just a list that we talk about in the reference guide and in the trainings related to healthy housing, that these are the kinds of things that we're trying to remove from the home environment. Your students would learn all about each of these different types of contaminants and why they're important, but this also indicates why ventilation is so important to a wide array of contaminants. It's not just one particular target compound you're trying to remove. It's a wide array of things that need to be removed from the indoor environment, either through exhaust or through proper circulation and filtration, so that we eliminate people being exposed to these contaminants in the indoors. Your students will also learn about some basic concepts related to building science, this concept of infiltration, moving from higher pressure to low pressure, which comes from the outside to the inside, or from an outer space, whether it's an attic or crawl space, infiltrating into the indoor environment, or the opposite being the exfiltration, again, moving from high pressure to low pressure, where air is moving from the inside to the outside, all of it driven by pressure differentials that are either caused within the system or from outside influences. And all of that is discussed and described in detail in the Healthy Housing Principles reference guide and in the training. Your students will also learn what we now know about some of the pollution science associated with just regular cooking. Just daily cooking activity turns out to produce a whole host of different kinds of very hazardous compounds and cancer-causing agents through just the normal daily routine of a cooking process. So it's vital. It isn't just that we want to remove smoke and vapors. It turns out there are significant pollutants that indoor range or exhaust fan in a kitchen really need to be in place and exhausting all the way to the outside in order to make for a healthy indoor environment. So it's important that that operate correctly, but also that it be quiet, because people won't use systems that are too noisy. Finally, what your students will learn is about the wide array of point sources that need good ventilation. It turns out that a lot of building code around the country mandates some of these things have to have some kind of exhaust fan, but others don't. And it's important for your students to understand which ones it might be mandated for, like a stove or an open flame, and those that it might not be mandated for, depending on the community. So within the training, we go through in detail all of the common sources that need exhaust ventilation, and where those sources are located, and what kind of flow rate you might need for any one of those individual sources.
I think one of the things that's coming throughout this session and will be reiterated in part two is that there isn't one clear separation between one of the keep it principles and the other. You can see how one kind of evolves into the other. and ventilated is something that is now, again, because of the COVID-19 virus, has made people much more aware of what's going on in their house and how they can control the air exchanges that are happening. They're no longer dependent on whether or not their home is leaky to actually allow fresh air or outside air to come into their house. So, we talked a lot about exhaust ventilation, which is then causing something else to come in through the walls. You also have supply ventilation, which is kind of a new challenge for many of the contractors that are out there, is how to get this and how to get that to work with your exhaust system so I can bring in fresh air through my system or through a direct mechanism. All that is leading towards the real holy grail of actually great ventilation, which is a balanced system. These can be a combination of the exhaust and supply, or it could be a single unit that's actually pulling air from outside in, mixing it, taking out air from the inside from places like bathrooms or other places that don't have the best air, and replacing it with outside air that's going directly to bedrooms or places where you're working. These are the kind of things that are showing that there are cognitive improvements and people are getting the best out of their home when they have these kind of environments. Wherever you're sitting right now may not have the best ventilation. Your classrooms may also struggle with these kind of conditions. So this is something that we're very aware of, and it's just now come of age. This is something we must conquer in terms of the contractor. And the only thing that really comes to mind is that the HVAC contractor, you are clearly one of the most important contractors of any facility, as well as you're one of the only ones who's invited into homes regularly to repair, analyze, and fix these things. So your importance on the occupant's health is crucial. And we want to make sure you stress that to your students. You're not there to service equipment. You're there to make people healthy and make their environment better. This is now the newest concept that really is hit, is that we just do continuous ventilation, and usually it is actually exhaust only. So there are ways to make this better by adding supply. But in general, we do, I also personally make sure that you're using something that's a verified system. I'm sure that's something you are talking to your students about. Most of them have that. So this is the new ventilation standard, which is just a single fan and just runs and runs throughout the hour off and on to create that. So again, think hard about where that replacement air is coming from. I'm going to give you an example about how much air is actually being removed and replaced by these simple exhaust only systems. Okay. So what we're going to have here is the upper part of the floor is a bathroom fan. The bathroom fan is only going to run for 20 minutes. Down below, we have a kitchen fan, and it's going to also run for 20 minutes. The fan above is the minimum 50 CFM. The kitchen is a minimum 100 CFM. So under 20 minutes of runtime, here's the cubic feet of air that actually will be removed, and remember, will be replaced. This is actually just a solid replacement between A and B, but imagine that when the air comes in, it's coming through the attic, the crawl space, throughout the walls, anywhere it can. But the exercise here is so you can see the volume of air that's being replaced. So you can see, starting now, we're going to exhaust from the one side of the house and show you the volume of air that's replaced on the other. It's a significant amount in just 20 minutes. Most people don't run sometimes their exhaust fans for even 20 minutes. So if you're good and you run it longer, you can imagine that this is twice the amount of air that's actually coming out of your house and also somewhere coming into your house. So this is where the contaminant pathway and other exposure pathways now become much more significant in terms of how you control the environment, why your attic needs to be sealed, why the walls need to be sealed, and crawl space. This is why the air is being replaced on a regular basis throughout the day.
It is clear that the national pandemic has changed the way we see and experience our homes. Now is a great time for you to help your students adapt their technical ability in HVAC to growing customer concerns about how their home affects their health. In part 2, tomorrow, we will discuss why healthy homes matter and the 4 remaining keep its. Keep it contaminant-free, safe, comfortable, and maintained.
For those of you that are interested, all of the references that were used in the development of today's presentation are available at the Healthy Housing Principles Resources website that BPI has developed, along with the Healthy Housing Reference Guide and exam. If you go to the website here, there are these buttons that you can click on that will take you to the educational materials, the key references, keep you aware of Healthy Home conferences, some of the new and important publications. individual resources by chapter, copies of some presentations and webinars related to health and housing. And you can see there's even a section related to pandemic information and information about managing houses and buildings. So it's a great website to get resources related to health and housing.
What makes this phenomenal is that it's constantly being updated, and it wasn't just put into a book that would then you struggle to find out what's the newest and greatest information. So it's a great resource. It's always there for anyone. So today we actually provided lots of resources and great information about the Building Science Principles Reference Guide. And here's the link. Healthy Housing Principles Reference Guide. Here's the link to that. And again, as we mentioned before, here's a link to some of the presentations and other recordings that we've done that you have access to view and to use as needed. There's also, if you want to learn more about the Train the Trainer and the learning network that we're developing, please send us an email to hhlearningnetwork@gmail.com. So here's our contact information. Please take a screenshot of these if you want to contact us at any time. So again, from Joe Medosh,
Kevin Kennedy,
And Larry Zarker.
we are the Three Sages. We appreciate you being here today, and we look forward to helping you in any way with you and your student and your curriculum. Have a great day.